electron density is given by the square of the psi function, which is the wave function. So wave function given by Schrodinger was psi. Square of that gives us the probability density, means probability of finding an electron in that region. Variation of psi square with respect to r, that is radius. If this is the orbital and here this is the center, that is nucleus, and we move away from the nucleus. So if we
सर
move,
सर
yes,
सर ये श्रोडिंगर इक्वेशन वैसे हमारे एग्जाम्स में आती है.
equation as such, no. But what I am telling you that psi square is probability density function, that can be asked. But as equation. So if we move from the nucleus outward, so this is actually the distance from the nucleus. So r is not here radius, rather this is distance from the nucleus. Distance from nucleus. So if we move from nucleus to outward, what will be the density of electrons? If electron density is higher, means probability of finding an electron in that region is high. And that density is given by square of wave function psi. Now here two diagrams are given, two graphs actually of 1s and 2s. I draw a line here. The left side is for 1s, the right side is for 2s. Means s orbital of first shell, s orbital of second shell. That is the difference only. Otherwise, both diagrams are for s orbital. So what we see, if we move away from the nucleus, means 0 is origin, nucleus position. If we move away from this one, then psi is decreasing. This is psi, and this is psi square for 1s orbital. So we know that psi square will give us the electron density, not psi. But for that, we need to know first psi, because we will square this to get the density. So these two will give us the probability density. Probability density means the density of electrons within the orbital, means probability of finding the electron is maximum there. For 1s, for this is psi for 1s, psi for 2.
Sir, can you please go back to the previous slide? Yes. Okay, sir.
Now I'm considering only first here 1s. So I'm considering this part first. This is psi. I square this function, I get psi square. So it is decreasing. As you see, psi decreases with distance from origin. So square will also decrease, that is fine. It will decrease with more rate or higher rate if we do square, but it will decrease. So in this case, it is obvious that when you move away from the nucleus, say this is 1s orbital, and if you move away from the nucleus, the density of the electrons will decrease. So here the density will be maximum, and then it will decrease, and then towards the end, it will be minimum. Maximum will be towards the nucleus, because here if you see at this point, the density is very high. But after that, it decreases very rapidly. So if I talk about at this point, it decreases rapidly. Away from the nucleus, probability density decreases. Now consider the second one, 2s. This is for 2s. This is psi, this is psi square. Here there is something different from 1s. And why it is different? Because here the psi function which is the wave function, is not uniformly coming down. Rather, it comes down first, then increases. Right. When you square this one, you get the positive, because square will always be positive. And one point here where students get confused. Actually, zero is this line. Zero here is this line. Otherwise, if you consider this one as zero for y-axis, you will never get this type of square. Because if this is zero, this whole will be positive. If it is positive, the square will be positive. So zero for y is here. Now understand what I am saying. If this is 10, square of this one will be 100. If this is 20 psi, square of this will be 400, somewhere here. But square of zero will be zero. That is, it will come down at this position. The square will be zero. After that, if it is say -5 here, -5 whole square will be 25. Means it will be positive. Hence, it will further start increasing from. So after zero, although psi goes in negative direction, the psi square will go in positive direction. Will go in positive direction. So if I say at this point here, yes, it is -5. At this point here, it will be 25. And it will keep on increasing till here. Maximum negative here. So maximum negative, say maximum negative here is -8, -8. So 8 square will be 64. It means maximum peak here will be around 64. And after that, it will again increase. Say again it is -5. So at -5, it will again be 25. And so on. And here it touches zero again. This is zero line. Because this touches zero, all these values correspond to zero. So what this graph tells us that the density of the electrons here, psi square gives density of electron, becomes zero at this point. So when we move from origin, after some distance, the density of the electrons becomes zero, and then again it increases afterwards till here, and then again decreases. It means if you have 2s here and you move away from the nucleus, initially the density will be high, this region, but it will decrease. From nucleus, it will decrease. But after that, it will become zero. So for some reason, there will not be any density. This region will be empty, no electrons here. And then again, electron density will increase. So this region will not have any electrons. This region will correspond to zero. Psi square value, zero. If we see these diagrammatically, for S, the electron density will decrease uniformly. When you move away from the nucleus, electron density decreases because psi square decreases gradually. But in case of 2s, if you move from center, for this region, electron density decreases. But in this region, hole, there is hardly any electron density, minimal electron density. Very
Sir, means this gives us the region of delta R, sir, with respect to the radius we are considering, sir.
psi square.
Yes,
Value of psi.
so means the area of the smaller R is subtracted from the area of any bigger R we are considering, sir. According to that.
Well, if you want to visualize, not area, volume, because
Yes,
it is
sir.
3D.
Yes, sir. Not a. Yes, it's 3D. Yes, sir. Sir, so it means, sir, that sir, so these radius you are considering, sir, are these, sir, within the nucleus and or
Within the
outside
nucleus and within the orbital. So I'm talking
orbital?
about within the orbital. If I am talking about 2s, within 2s orbital only. And 2s
Okay.
orbital is just part of the atom.
Yes, sir.
So within orbital, there will be some region where you will have very low probability of having the electron. And after this, again, the electron density will decrease. I go back here. First, electron density decreases almost to zero, then again increases, and then decreases. So that's what we have here. Electron density first decreases. It decreases to,
Sir, can you please repeat it?
yes, just a second. So first I am saying here electron density decreases. Okay, electron density here decreases. It becomes zero here. Then again increases. And then again decreases. So here it is zero. Here it is maximum. Around the nucleus it is maximum. Then zero. Then again increases to some value. Okay.
The
This value
positive
is not
value, sir.
some positive value, but not maximum. Maximum will be around nucleus only, and then decreases again. Now you can see that some density is still shown outside the s orbital. This is because there is no clear demarcation. We say that 90% around possibility is there that electron will be in 2s orbital. So there is no strict hard line or image. This is just imaginary line. No strictly defined boundaries which can say that electron cannot go outside it. So this boundary line just shows that 90 to 95% possibility is there that electron will be here. 5%, 5 to 10%, it can be outside also. So these do not have clearly defined boundaries, although we say that this is the distance from the nucleus. These are not clearly defined boundaries. Yes, there was some question. Fine. So the region where this probability density function reduces to zero is called node. So here, or nodal surface. So here in this case, this region is actually the nodal region. In general, it has been found that ns orbital means 1s, 2s, 3s, etc. has n minus 1 nodes. These formulas are required. Very common questions will appear from here. Total nodes n minus 1. I will be talking about two nodes, two types of nodes. Total number of nodes n minus 1. So if I say 1s orbital, how many nodes will be there? 1 minus 1, that is 0. That's why this 1s does not have any nodes according to this formula. 2s, this is 2s means 2 minus 1, that is 1 node which is there. So 2s orbital will have 1 node, 3s will have 2, and so on. This node in this case is called radial node. Okay, I said there are two types of nodes. The first one here is radial node. Why it is radial node? Because it is spherical. If you visualize it inside a ball, 3D ball, you will see that this is a smaller ball, this is larger ball. So within larger ball, you have a smaller ball. Within this region, the probability of finding an electron is minimum. And because it has radial shape, that's why radial node, spherical shape. Now there is another type of node also. If we consider p and d orbitals, p orbital is something I told you like this. Here it is shown like this. Okay. If you consider p orbitals, there are three p orbitals, px, py, pz. You notice one thing. You notice that, suppose I am talking about pz. This is along z-axis, but the xy plane, if you consider xy plane, in xy plane, there is no electron density at all. In this whole plane, there is no electron density because no electron density is here, no electron density here, no electron density here. Between these two lobes, there is no electron density. Okay? If you separate these two lobes, suppose this one and this one, here there is no electron density. So this whole xy plane does not have any electron density. So this is again defined as nodal plane. So xy here is nodal plane. Nodal plane means the density of the electrons is zero along this plane. It is along x, so nodal plane will be yz. It is along y, so nodal plane will be zx.
X3.
Okay?
Yes, sir.
It is along z, so nodal plane will be xy. So
X1.
whatever is along, apart from that, whatever two are there, those will form the nodal plane. Simple. So if it is PZ, XY will be nodal plane. EY, ZX will be nodal plane. Z, XY will be nodal. Other two will form the nodal plane. Besides the radial nodes, the probability density function for NP and ND, that is P and D subshell, are zero at the planes passing through the nucleus origin. For dxy, so if you see dxy, dxy itself is in xy plane. So if you see dxy is itself in xy plane, but there are two planes which pass through the center and do not intersect the lobes. Those planes are xy plane, this one. Okay, this plane, if you see, does not pass through, so it passes actually through here. Through here. So this plane which passes through here and then downward also does not cut any lobe. It just passes through the center. The probability density here, that is electrons, are not present in this region. So that's why this will be known as, for example, in this case, it will be Z and X plane. One
Excuse
plane
me,
will be
sir.
here.
Sir, I can't see your screen, sir. Can you turn on screen sharing once again, please?
Others are able to see my screen.
Yes, sir.
Yes, sir.
It
Yes,
means,
sir.
Yes,
it
sir.
means
Yes,
you need to
There's
log in
some
again.
glitch.
It means you need to log in again.
So it's a network issue.
Yeah, you need to just log out and log in. You will get the screen. So
Sir,
here
can
you
you
will
please
have,
explain this again?
yes, I am explaining that. So in this case, if you have Z and X, this plane is actually like this. Then this plane has these two lobes on one side and these two lobes behind it on the back side. And along this plane, there is no electron density at all. The electron density is zero. So ZX plane in this case does not have any electron density. So that is a nodal plane. This is one. Another one is this one. If you can visualize it in 3D. This plane also, these two lobes are towards us and these two lobes are on the back side of the plane. So these two are at the front, these two at the back. But in between, if you see here, it is passing through the origin center, no electron density at all. So this is again Zy, or you can say YZ plane. These two planes are nodal planes in this case. Okay. Now, how you find it? For example, for PZ, I told you it is easy. For PZ, it will be XY plane. For PY, it will be ZX plane. For PX, it will be YZ plane. Similarly, for DXY, it will be, you have consider X with other one first, the X, and consider Y with other one, YZ. So the remaining is Z. You will consider Z one by one with both. First with X and then with Y. Those will be the two nodal planes. So if you are asked which two are nodal planes for D YZ, it means X is remaining, you will consider X once with Y and once with Z. X is remaining, you will consider X one by one with both Y and Z. Those will be the nodal planes. So total node planes will be radial nodes, total nodes basically radial nodes, plus these nodes are known as angular nodes. The nodal planes are known as angular nodes because these are at an angle, mostly 90-degree angle with the plane. So that's why these are known as angular nodes. These are called angular nodes, and number of angular nodes is given by L. One angular node for p orbital, two angular nodes for d orbitals, and so on. This is something you have seen. Okay. For every p orbital, you will have one angular node. 3p orbitals, three angular nodes. For every d orbital, there will be two angular nodes. Yes,
Sir,
yes.
sir, what are radial nodes?
Radial nodes are those ones which are spherical, as we discussed in case of s orbitals. These are radial nodes. Regions where the electron density is almost zero.
Okay, sir. Okay, sir. Understood.
Radial nodes are spherical and angular nodes are planar. Total number of nodes will be radial nodes plus angular nodes. Total number of nodes, this formula I have already told you, n minus 1 at the beginning. Total nodes are found as n minus 1. But if you are asked separately how many radial nodes are there, how many angular nodes are there, angular node formula is straightforward. Angular nodes, the value of L, S, P, D, F. The value of S is 0, P1, D2, F3. These many angular nodes will be there. Means in S, you won't have any angular node. There will be only radial node. In P, there will be one angular node. In D, two. In F, three, and so on. Radial nodes formula n minus L minus 1. N minus L minus 1. Radial nodes will be there. So suppose I say that in third shell, how many radial nodes will be there? Radial and angular. Radial nodes will be 3 minus. If I am talking about p orbital, I will say 1 minus 1 for p.
Sir, one.
Okay.
Only one in R.
Okay. Means radial nodes will be 1. Angular node
Yes.
value of L only. So L is 1. Radial node value is L only. Angular node value is L only. It means 1 radial, 1 angular, total 2. And if you apply this formula, 3 minus 1, total 2. You need to remember all three. Okay. Questions are very easy. You just need to remember the formula. Once you have understood what we mean by nodes, nodes are those regions within the orbitals where probability of finding an electron is minimum. I'm writing it and you need to memorize. Number of radial nodes n minus L minus 1. Number of angular nodes L. Total nodes, sum of these n minus. Radial nodes along the radius, angular nodes along the planes. Now we are talking about
Sir, can
energy
you
of
please show those formulas for a second?
yes.
Sir,
Yes.
sir, actually I opened the site exam classes today for notes. So sir, it showed that the site is under maintenance.
It was for 25 minutes till 11. So the message was written there that it will be under maintenance till 11 a.m. IST.
Okay, sir. Okay.
It was 25 minutes. Now energy of orbitals, and this is a very important section here because we will be talking about Aufbau principle here, which you will see in many questions. The energy of an electron in a multi-electron atom depends on its principal quantum number and azimuthal quantum number. If you remember, I said that principal quantum number largely decides the energy and azimuthal quantum number also decides to some extent. N plus L is actually the energy of any orbital. Energy of an orbital. Okay. Here basically I'm talking about the subshell. I'll show you how it is related to orbital. Is N plus L. So suppose I am talking about 2s, 2p, 3s, 3p like this. So energy of 2s will be 2 plus 0 because s corresponds to 0. That's why we talked about the values. That is 2.
So what is
2p,
the unit to this energy, sir?
no, these are just comparative. We will not be talking about these do not correspond to any energy. We will be talking about comparative values only.
Yes.
So 2 plus 1, 3. 3 plus 0, 3. 3 plus 1, 4. Now there will be cases where you will get same sum. 2 plus 1 also gives you 3 and 3 plus 0 gives you 3. In this case, n will decide the energy. Value of n will decide the energy, means value of n higher, energy will be higher. So in this case, 3s will have higher energy. 2p will have lower, though both have sum as 3, because in 3s value of n is 3 as compared to 2, and 3 is greater than 2. So rule should be very clear. And that's what actually scientists have found. Okay? That is actually what I'm going to talk about as Aufbau principle. That the of the orbitals, energy of the orbitals is decided by n plus L. But if the value of n plus L is same, then n will decide the value. Means comparative value only we are talking about. Hence, in this case, 3p will have energy greater than 3s, energy greater than 2p, energy greater than 2s. And this rule will lead us to some very interesting point, that the filling up of electrons in the orbitals will not be like 1s, 2s, 2p, 3s, 3p, 4s, 4p, 4d, 5s, 5p, 5d, 5f. In 1s, there will be only s. Okay. In second shell, there will be p also. I hope you remember that. Okay. If n is 2, we will have s and p both. If n is 3, we will have 0, 1, 2 value, means s, p, d. So in 2, you have only s and p. In 3, you will have s, p, d also, 3d. Okay. In 4, you have 4f also, for example. But it will not fill in this direction. The electrons will not fill in this sequence. And we will see how. Why? Why this is not possible that electrons can fill in sequence. For that, you need to remember what I have told you. The value of energy is decided by n plus L. If same, then by n only. However, for hydrogen atom, the energy of an electron is determined solely by the principal quantum number. Thus, the energy of orbitals increases as follows. 1s, 2s and 2p will be same. Why? Because energy is decided only by principal quantum number. So principal quantum number is same in 2s and 2p. Same. Similarly, here 3, 3, 3, same principal quantum number. And energy in hydrogen atom decided by only principal quantum number. So you will keep all these equal. The value of n, 1 here, 2 here, 3 here, 4 here. So increasing order of energy will be like this for hydrogen atom only. And you need to remember this. This is common mistake when this question appears. You forget that for hydrogen atom, Aufbau principle does not apply. The orbitals which have equal energy are called degenerate. I will be using this term very frequently. So memorize what I am saying. Degenerate orbitals are those orbitals which have same energy or almost same energy.
सर बट सेम तो किसी की होती ही नहीं, क्योंकि अगर n बड़ा होगा तो उसकी एनर्जी ज्यादा हो जाएगी.
These have same. Okay. And when we will be talking about the orbitals, for example, 3 orbitals in p.
Sir, but only for hydrogen?
No. Okay. No. Within this 3p, for example, for other elements, 3p will have p subshell, will have 3 orbitals. These 3 orbitals are degenerate. When I say 3p, it actually means 3 orbitals. So these 3 orbitals have equal energies. These are degenerate. Similarly, in D, there are 5 orbitals. These are degenerate normally. I'm not saying that these will have exactly same energy. That's why I have used the keyword here, almost same energy. Then also these are known as degenerate orbitals. Yeah. Degenerate orbitals are those orbitals which have almost same or same energy. The 1s in hydrogen atom corresponds to the most stable condition. Why? This is a thumb rule you need to remember. If energy increases, stability decreases. And you can remember this fact by, if you have water at normal temperature, it is stable. But if you heat it, it starts boiling and becomes unstable. Means if energy increases, it becomes unstable. And this is the rule in the universe, thumb rule in the universe. If energy is higher, it is unstable. Okay. So suppose you uh, are calm, cool, so your energy at that time is low, right? But suppose you are angry, your energy is very high, then you are not in a stable state of your mind, you are unstable at that time. So that is law of universe. Lower the energy, greater the stability. And you need to remember that applies in chemistry as well. Lower the energy, greater the stability. Another example from chemistry perspective, for example, you have calcium carbonate. If you heat it, it will get decomposed. You heat it, it will get decomposed in calcium oxide and carbon dioxide. It means it didn't remain stable. It got broken with heat. If it would have been stable at higher temperature, then it would have not decomposed. So lower the energy, greater the stability. This rule we will talk about again and again in chemistry. So that's why 1s in hydrogen atom is most stable because its energy is 1 plus 0, that is 1. Least energy, most stable. An electron in 2s2p or higher orbitals in hydrogen atom is called in excited state. Then next topic, shielding effect. And more about shielding effect I will be talking about in a periodic table. But for now, just an idea about shielding effect. Due to presence of electrons in the inner shells, this is the atom. And say this is one shell, imaginary shell, n equals to 1. There is no physical boundary line. This is just imaginary boundary line. N equals to 2 and so on. So what happens? Suppose this is that. N equals to 3, n equals to 4, like these are shells. Now the electrons which are there, say n equals to 4. This is the electron. Okay. One of the electrons I have talked about. Okay. So this electron will, if there are no other electrons, will have some force of attraction by this nucleus. So this nucleus will attract this electron towards itself. But in reality, what happens? There are electrons in between also. Suppose here also. These electrons, which are in the way between the outermost electron and nucleus, these electrons actually reduce the force of attraction. These act as shield between the outermost electron and nucleus.
Sir, it means that the nuclear forces of attraction are reduced due to the electrons obstructing electrons in the outer shell.
Electrons in the middle shells.
Sir, in
Yes,
the
sir, they
inner
are
shell,
obstructed by the
just before the
electrons at the middle.
Yes. So
sir,
if
the
there
shells
are,
before the octave.
come again.
Sir, the shells before the outermost shells, no? Sir, they reduce the
Yes, before the
positive.
outermost shell. So the inner shells, these are inner shells, electrons in inner shells. So these obstruct the force of attraction between nucleus and outermost electron. And hence, the force of attraction between the nucleus and outermost electron decreases. It is not as it would have been without the electrons, intermediate electrons. Intermediate electrons means these electrons. These electrons have shielding effect. Why shielding? If you remember, shield is something which protects. So earlier kings, etc., warriors used to have a shield uh, in the war. So shield means protection. So this also blocks the force of attraction. This is known as shielding effect. So now I'm reading it, what is written here. Pratyush, what you say? You say as energy of orbitals is determined by n plus L, like 2p and 3s both have same energy. In this case, we will consider n to decide energy. So how orbital can have same energy? Okay, actually I didn't get your question. Whether you are questioning the atomic structure, that why atomic structure is designed so it should not have the equal energies in the orbitals. So I did not get your question. But if I get you correctly, you are trying to say that two orbitals should not have equal energy. Why do you think so? Why two orbitals cannot have equal energy if they are of the same subshell? If orbitals belong to same subshell, what stops them, what checks them not to have the same energy? If I could understand you, that is my question. Okay. So
Sir,
my
by
answer
same
after it,
subshell, by same subshell, do you mean that the shells can vary?
by
Or
same
sir,
subshell I mean D. For example, if it is 5D, 5D subshell will have 5 orbitals,
yes,
and
sir.
these orbitals can have almost same energy
Yes, sir.
because these all belong to D subshell.
Yes, sir.
So these 5 will be called degenerate orbitals in that case. Although in crystal field theory, we will talk about that 3 will have same, 2 will have same, but that is something I will talk about in, different chapters, not yet. Okay, so coming back to shielding effect. Shielding effect is the reduction in the force of attraction due to intermediate electrons, in simple terms. Okay. So due to presence of electrons in the inner shells, the electron in the outer shell will not experience the full positive charge on the nucleus. This is known as ZE. E is nuclear charge. Okay. But will be lowered due to partial screening. So that's why it is also known as screening effect, shielding effect, screening effect of positive charge on the nucleus by the inner shell electron. Now, it is also called effective nuclear charge. So I'm using two terms here and you need to understand because these terms appear interchangeably. Either you say reduction in force of attraction or you say effective nuclear charge is reduced. Okay. So what it means? It means that suppose earlier I had 15 protons here and 1 electron here, outermost electron one. So there will be some force of attraction. If I apply normal formula, the formula will be, force will be proportional to Q1, Q2 by R square. Charge 1, charge 2 divided by R square. This is, you should have studied in physics. But suppose due to the inner electrons, these electrons, this force is reduced. So say earlier it was 15 into 1 divided by some x square. So effectively, it would have been 15 divided by x square, but say it is not 15 divided by x square, it is rather 12 divided by x square. It means I can write it at 12 into 1 by x square. It means instead of 15 nuclear charge is now being considered as 12. So that's why we call it effective nuclear charge also. The reduction in force of attraction, I'm repeating, the reduction in force of attraction due to shielding effect is also termed as effective nuclear charge, because effective nuclear charge is actually less than what it could have been in absence of inner electrons. If electrons were not there, inner electrons, the charge was 15. But due to that, the force is less, and effectively that charge behaves as it is only 12, not 15.
So the arrow should be outwards, right? So the arrow of
Which arrow?
sir,
Which arrow?
that you have made in a diagram, so towards the nucleus.
I'm saying that this electron is attracted by the nucleus. So I'm just writing as per my statement. This
Okay, sir.
electron is attracted by the nucleus. I am not drawing the dipole moment here. I'm not talking about the dipole moment. I'm talking about the force. Okay. Force of attraction. Dipole moment will be from plus to minus. So this is known as shielding of the outer shell electrons from the nucleus by inner shell electrons. As a result of shielding, the net positive charge experienced by the electrons from the nucleus is known as effective nuclear charge. Effective nuclear charge is less than the actual charge. It is denoted by Z effective instead of Z. And Z effective E will always be less than Z due to shielding. Shielding is simple phenomenon, means there are few electrons in between the nucleus and outermost electrons, due to which the force of attraction between nucleus and outermost electrons reduces. Force of attraction reduces, and it is analogous to that the nuclear charge got reduced, and that reduced nuclear charge is known as effective nuclear charge.
Sir, I had one doubt, sir. In the last slide, sir, you had given us that F is directly proportional to Q1, Q2 upon R square. Sir, in that, sir, does Q1, Q2 represent the charges, sir? Like the
Yes,
positive and the
yes,
negative
yes.
charge?
Yes, charges. Charge. If you have not studied that in physics, you will study that in physics, right? Similar to
Yes, sir. Sir, in ninth we had studied G equal to Gm1
right,
M2
the
upon R.
force of gravity you
Force.
have studied, for example, m1 m2
Yes,
by
sir.
d square. Similar to that one, the force of attraction is between the charged objects also. Obviously, both have to be oppositely charged, then it will be force of attraction, otherwise it will be force of repulsion. So this is force between any two bodies, gravitational force. And when I say this one, this is force of attraction between two charged bodies, which is similar to force of attraction between any two bodies. Then we talked about lower the value of n plus L, lower will be the energy. If two orbitals have the same value of n plus L, then lower value of n will have lower energy, higher value of n will have higher energy, means n will decide the energy in that case. Energies of the orbitals in same subshell decrease with increase in the atomic number. Now this is very important, because sometimes you are asked to arrange the energies in increasing order or decreasing order. And there you get confused. For example, if I talk about 2s, second shell will be in uh, s orbital in second shell will be in many elements. Okay? For example, lithium can have, sodium can have, potassium can have, all will have 2s. But how will you say which 2s will have higher energy? So I am not talking about the same element. This is specifically when I am talking about 2s orbital of different elements. In that case, you need to remember the rule. Energies of the orbitals in same subshell decrease with increase in the atomic number. Means if atomic number is increasing, here atomic number 1, 3, 11, 19, atomic number is increasing, the energy will decrease. So here highest energy, then lower, lower. Potassium will have lowest. So 2s orbital of potassium will have lowest energy. Lowest energy, highest energy, all have 2s. Okay. Why I am telling you this? Because 2s will give you 2 plus 0, that is 2. So its energy is 2, this energy is 2, this energy is 2, this energy is 2. So as per n plus l rule, you will say all should have equal energy, but that is not true. If we are talking about the same element, then that rule applies. Now here we are talking about different elements. Same subshell in different elements will not have same energies. Same subshells of different elements will have different energies. So if you move towards higher atomic number, the energy will decrease. It means 2s orbital of hydrogen is out of these four most unstable. Why? Because energy is highest. And 2s orbital of potassium will be most stable. When I say most unstable, most stable, I am comparing only these four, not with other elements. Lowest energy, most stable. Highest energy, least stable or most unstable. Write down this rule also. And this actually appears normally in JEE and NEET because there they want to confuse you. In CBSE, normally you will get comparison within the same element. Aufbau principle. This is one of the most important principles of this chapter.
Sir, please show the previous slide.
Done?
Sir, just a minute, sir. अभी भी आएंगे. Yes, sir.
Okay. So Aufbau principle, Aufbau actually
Yes, sir, done.
means the arrangement in energies. Arrangement according to energies or increasing, decreasing order. So Aufbau is not the name of the scientist. In the ground state of the atoms, the orbitals are filled in order of their increasing energies. This is Aufbau principle, which will help you to write the electronic configuration of almost all the elements. There are few exceptions we will be talking about. Aufbau principle says that within one atom, electrons will get filled up in order of their increasing energies of the orbitals. So if I say 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, One will have only S, two will have S and P, three will have SPD, four will have SPDF. This is something you know. So if we write this, we will think that probably the energy should get, the electrons should get filled up in this order. So first electron should go to 1s, second should go to 2s, third should go to 2p, and so on. But up to certain extent, it is true. But after that, according to this rule, it will change. Write the energies according to this rule. 1s will have 1 plus 0, that is 1. 2 plus 0, 2. 2 plus 1, 3. 3 plus 0, 3. 3 plus 1, 4. 3 plus 2, 5. 4 plus 0, 4. 4 plus 1, 5. 4 plus 2, 6. 4 plus 3, 7. Now, do you see there is not increasing order of energy actually in this region? In this region, after 3p, it's not 3d, rather it is 4s, which has the energy less than 3d. Between 3p and 4s, which will have higher energy?
The
Both have
4s.
4s, right?
4s.
Because here n will decide the energy. If the sum is same, then n, that is here 4 is higher, 4 is greater than 3, it will decide the energy. So after 3p, it is correct. It is correct because it is increasing order. Up to here, it is correct. But after that, the electron will go into this. If there is one more electron, we are increasing the atomic number, okay? It will go to 4s, not 3d. After that, you have two 5s. Which one has lower energy out of 3d and
The
4p?
3D.
3d has
3D.
lower energy.
So
So after 4s, it will go to 3d. And 5, again 5, this one is higher. After that, it will go to 4p. After 4p, 4d, 4f, normal. So you see the sequence is not as expected. Sequence is rather as per the energies, increasing order of energy. Now, how do you find this sequence? How can you write these orbitals so that you get this sequence very easily instead of writing in this manner and getting confused? There is a way to write it. You will write it as how many orbitals can be there in a shell. So for n equals to 1, there will be only one s. So you will write only one s. For n equals to 2, 2s, 2p will be there. For 3, 3s, 3p, 3d, up to d orbitals. 4 can have s, p, d, f. So 4s, 4p, 4d, 4f. 5 will have s, p, d, f, g. G we are not writing because, up to here, we will see that only 8s will be required. Although, if we go forward, 8g will, 5g will be used. Now, how to draw the sequence? The sequence will be as shown in the diagram. It will be 1s. After 1s, it will go back 2s. After 2s, it will go back again 2p, 3s. After 3s, it will go back 3p. And if you see after 3p, it is not 3d, rather it is 4s, which is as per the above principle. After 4s, yes, you go back, then it is 3d, 4p. After 4p, it is not 4d. It is not in the same shell, rather from 4p to 5s. And after 5s, it is not 5p. No, rather it is, you go back, it is 4d. And after 4d, 5p, and so on. With practice, you even don't need to look onto this diagram. Okay, you will memorize the electronic configuration up to here, at least to 7s. It is very easy when we do the questions. But first you need to understand that above principle is the filling up of electrons in the orbitals is in increasing order of the energies of those orbitals, not the sequence as defined as per 1s, 2s, 2p, 3s, 3p, 3d like that. This is known as upper principle here. And you need to at least draw it once to understand how the electrons are built up. So as you can see here, all the electrons here have energy level 1. All the electrons here have energy level 2. All the electrons here energy level 3. All the electrons here energy level 4. Energy level 5. Energy level 6. So all the oblique lines actually have same energy level. Energy level will be same, for example 7 here. But depending on the number of orbitals, for number of shell, 4, 5, 6, 7, the energy will increase. Otherwise, n plus L value is same.